Alright, so I am quickly going to be going over how to look at a graph and creating the piecewise function equation. This is mainly for my 6th period who I needed to end the meet early for. Again, I am so sorry. So here, I'm not going to do all 3, but I am going to do this one over here. Now, what I was telling my other classes in class was there are multiple ways you can look at this graph. Either you can look at it in 3 parts, which is what we're going to do. We're going to look at this like this is part 1, this is part 2, and then this over here is part 3. So either you can break it up and create the equations, find the equations for these 3 different parts, or you could notice that part 2 and part 3 together, they form an absolute value function. So you could create a piecewise function that only has 2 parts, a linear line down here, part 1, and then also the absolute value up top. Or a third way that you could look at this is when you combine part 1 and 3, notice that this is a linear line, just with the middle portion missing. But like I said, we're going to split this into 3 parts just so we can get more practice with finding equations for lines. So it doesn't matter, this doesn't define this as any function, so I'm going to just create a letter. I'll do h of x because I'm sick of f of x. And we're going to be, because we're breaking it into 3 parts, there will be 3 lines of equations with 3 lines of restrictions. So all 3 of these, if I'm breaking them into 3 parts, all 3 of these are linear lines. And a linear line we know is y equals mx plus b in standard form. M is our slope and b is our y-intercept. So we do, for each one of these, need to find the slope and the y-intercept. Okay, so first we need to find our slope and our y-intercept for that part 1. Now we find slope by doing rise over run, so you go from one perfect point to another. My rise here is 1 and my run is 1. So for this part 1, my slope is 1. So that means in front of our x we would have a 1, but that can become invisible. We don't need to write the 1. So it's just x. And then I'm looking for my y-intercept. Well, clearly this portion of the line isn't touching the y-intercept, but if we were to pretend that this continued on, we would see that this line intercepts the y-axis at 0. So here my b value is 0, but anytime we're adding 0 to something, it really does not need to be there. Anything plus 0 is itself. So our equation for this part 1 is just x. But now we do need to state the restriction. We need to state which x values do we have for this part 1 line. And you can see that it starts right here at this point with the x value of -2. And this line is graphed when all x values are less than -2. And notice it is a closed dot there for that -2. So we put an equal to sign below our less than symbol. Now let's find part 2. Same process. You have to find your slope and your y-intercept. So I'm going to go from one perfect point to another. My rise here is 1, but my run I'm going -1. I'm going in the negative direction 1. So 1 over -1 is just -1. And again, whenever you have a 1, it can become invisible, so your equation, for the first part at least, is -x. And we look, what is our b value, our y-intercept? It is again located at 0. So we can put plus 0, but it's not needed. It's extra work, extra writing. We can just leave our equation as -x. But then we still need to state for which x values is this line graphed. We are between the x values of -2 and 0. Notice it's an open dot there on that -2. So we're between -2 and 0, and it's an open dot for that -2, so I just put a less than symbol without an equal to sign below it. And it is a closed dot there, so I am going to put a less than or equal to sign for the 0. Then lastly, same thing, part 3, have to find the slope. My rise here is 1, my run is 1, so my slope is again 1, so it's just x. And then my y-intercept again is 0, which, remember in the beginning when I said that part 1 and 3 could be considered the same line with the middle portion missing? So it makes sense that 1 and 3 would have the same equation, just with different restrictions. So now we look, what x values are we graphing part 3 for? We start at 0 and keep going up infinitely, meaning we are graphing this part 3 when x is bigger than 0. Now notice that it is a closed dot there, but I am not going to put an equal to sign below that inequality because the previous line I gave the equal to 0. You can only have one line of restriction containing 0, containing a single or a single number. So what I mean by that is this is also perfectly correct to say less than 0 and then greater than or equal to 0, as long as only one of them actually gets the 0. 0 can only be accounted for one time. This is true for any number. Say instead of 0 that this had been 1. Same thing. Only one of these lines of restriction can actually equal 1. But it's 0, so let's put it back. This is because of the definition of a function. We're considering this entire graph as one function. So if we had both restrictions containing 0, it would actually create two y values at the same x value, which we know that if we have that, it is no longer a function. So if this is, say, -2, notice I have two y values here. Let's say that's 2, and let's say this is -1. So here, because for one x value of -2, I have two y values, this is not a function. The same concept applies down here. If I was to include the 0 twice, it would technically mean that I would end up with two separate y values. So it would not be a function anymore. Basically, you just have to remember, okay, I can only include, if I have to write a number twice, I can only actually equal it in one of my lines of restrictions.